for joining. And the idea behind this workshop is to really engage with the audience to build concrete solutions for the water management sector, together discuss some very challenging issues that we're dealing with on a daily basis in the NIADA's project, which is really about water management. And for this purpose, we have prepared for you a very diverse agenda, different sessions, to really try to grasp a lot of different themes revolving around water management. So for this presentation today, I will have the pleasure to chair this workshop with my colleague Juan from IMEN, hopefully to really guide the discussions and co-create some of this. I invite you all to go on the following page. So you all have a phone, a computer, any digital IoT device, normally at the IoT week. So whichever you like. Welcome, the man at the back.
Don't be shy.
Please come in. You're just on time. So the idea is for everyone to connect to the stage that we have over here. And we're going to be playing a little game together on water. So we're trying to make it as interactive and engaging as possible. Please let me know if you managed to access the page. All good?
All good.
Wonderful. So I will let you know more specifically when you need to go to it, but the idea is to have this one already ready on your phones. So everyone is set? Everyone has this page open? Yes? Everyone? Okay, I will project this again later on, but let's be on the same page. So I will be the first speaker. My name is Anna Hakim. I'm working for Manet International, and I'm a specialist in environmental science, international relations, and business management. And the focus of my research in the past years has been on sustainable development goals, and more specifically, researching on possible methodologies to support the achievement of sustainable development goals in the framework of research projects. So for today's session, I have prepared a little presentation on the water in the global agenda. And really I'm discussing what is the role of smart water in achieving the SDGs.
Anna, before you start the presentation, I think that we got the old link. It's not the correct one.
The link in the paper is probably not free.
Oh,
really? So if you can just please go back to the...
This?
Yep.
Yeah.
Let's
exercise
to digest.
Normally I have actually the address.
No, this was the official
I think this is the correct link, so that everybody should do that one.
Yeah, this is the one from Portugal.
Yeah. Please.
So if you want to take the good link, you should go on the screen.
Yeah, I'm copying.
This is certainly different.
Yeah? Okay. So is everyone good? Yeah, wonderful. All right. So I wanted to discuss with you a number of urban water issues that nowadays we're dealing with in the water section. Obviously, nowadays the water industry and the water sector has been facing a number of challenges, including rapid urbanization, which obviously leads to higher demand in the water sector. Obviously, also connected to some very challenging topics in the field of leadership and governance, really finding the right, correct political structures that are going to guide the policy making in the water field. Investment is also a big issue nowadays, really finding the right sources of income and cash flows to support the water industry, modernizing it, making sure that we are up to date with the new technologies, and really ensuring also that the infrastructure that we're using is up to date and making use of the latest technologies. Water availability and quality obviously is a big challenge nowadays, specifically in some more dry areas of the world, which can be affecting also the quality, hygiene issues, and last but not least, climate change, which is a big challenge for us, and that is going to play a huge role in the future of water. So this little diagram over here summarizes the main points I just mentioned. So you can see there's this interplay between climate change impacts, but also other environmental stressors that really affect the urban water management field and have a resulting impact on water availability and quality. So, smart water management and SDGs. What do we mean with smart water management? It's really when we're using ICT to provide real-time automated data for use in resolving water challenges and integrated water resource management. And when we look at the 17 Sustainable Development Goals nowadays, 11 of them are directly related to water. So we can definitely say that the water plays a dominant role in multiple of those. And smart water management has some important benefits on the SDGs, including the reduction of wastage through water leaks, also increased irrigation efficiency, and obviously health improvements, which are very obvious connections to SDG 6. The following diagram highlights this important interplay between the three sides, we could call it like that, of the SDGs. We have the societal topic and also the economy and the environment. There's a big interplay, especially at the level of Sustainable Development Goal number 6. And there's this overlap between those areas. I wanted to highlight a number of interlinkages between SDG 6 and the 2030 agenda. For social dimension, economic dimension, and the environmental dimension. And just to give you a rough idea, all of the SDGs that you can see currently on the screen are directly affected by SDG 6. So, for example, at the level of the social dimension, there is a connection with wastewater treatment, WASH, which stands for water, sanitation and hygiene also, which was directly related to SDG 6, but also poverty reduction, when you think about it, malnutrition, so hunger, also education, inclusion of women, girls in the politics regarding water. So there's a big connection to all of those mentioned here SDGs, and there's this continuous interplay that we can note. Same idea happens for the economic dimension, as nearly 80% of all jobs globally are dependent on water resources and water-related services. So it's really a dominant resource in those SDGs over here. And we can also note a big interplay between SDG 6 and sanitation, also interlinkages with productivity, participation of women. So the economic dimension is also very much affected by water. And obviously environmental, this is just a very non-exhaustive list of interlinkages between SDG 6 and the other SDGs here on the screen, but obviously climate is directly affected by this. Ecosystems, agriculture, but obviously biodiversity, marine pollution, and coastal ecosystems. All of these really come into play when we think of the environmental dimension in water. So in the course of NIADS, we have conducted a gap analysis of the current EU framework for smart water management, and we can note that a number of the directives are covering many of the SDGs. You can see here on the top the 17 SDGs, and each time we chose a color to indicate the extent of which each of those directives is discussing a specific SDG, and you can see that SDG 3, 6, 9, 11, and 12 are quite thoroughly tackled by the EU framework for water. But then other SDGs like SDG 1, 4, 5, 10, and 17, for example, are very limitedly addressed. And so there's a need as a niche for a better EU framework for smart water management, and something that probably we could be reflecting on in the future. So now it's time for our first co-creation exercise. So once again, I will kindly ask you all to take your devices, whichever ones you're using, and access once again the page. So everyone should connect to the following link, ahaslide.com/LGDCJ. And let me also open it on my side. So as soon as just give me 1 second. Okay. Normally, right now, you should be seeing the following question on your screen. Is that correct? Wonderful. So right now, this is the first question. Which are the main challenges about water management in cities? Sorry, sorry, this one. Let's start with this one. Do you know how much water the average European consumes per day? A regular citizen in Europe, how much does they consume per day? Please give a number. In liters.
In liters. In gallons.
Here we already can see some results popping in. Well, some of you are very optimistic, actually, and the closest that we have currently on the screen is 3,000. But the result actually is 5,000 liters per day across the entire water value chain. Well, you have to think also of the clothes you're wearing. Exactly. Your water footprint is much bigger than just... Exactly. So exactly, the consumption, the food that you're eating, obviously also is affecting the results. And there are different types of measurement, but obviously the average European, when you think about it, that is not following any specific lifestyle choices, is around 5,000 liters, which is quite a number. Next question. Are you doing anything to save water actively? So it can be personally, but also is maybe your water provider giving any solutions to you to help you
monitor or save water.
Sure, I couldn't get QR code. Can you just-
Yes. Just give me 1 second. It worked?
Yeah.
Okay. Okay. Some honest results, going from no to trying to. Reducing consumption wherever it can be done, reusing as much as possible in various sectors, controlling watering with sensors. That's good. Turning tap off when not using rainwater for watering plants, showering, not taking a bath, swimming outdoors. Yes, after washing vegetables, I reuse the water to give to plants. Smart. Installed shower water meters. Close tap when washing teeth, no bath, only shower, wear clothes for several times before washing them. Plant-based nutrition. Well, then we have already some quite interesting ideas and raising awareness with friends. Oof, it's coming in. Reducing the pressure. So it's interesting the number of different solutions that you're already highlighting here, and it's quite pleasing to note that we are aware of our water use and that we are doing already certain things to make it better. The water provider is sending notification about the usual water consumption. That's amazing. I do personally some actions, especially the car washing. The washing machine I have is designed to save water. Great. So a number of very concrete solutions here already on the screen. Yes, Alenka?
That's where one can buy shower water.
I'll tell you after the meeting.
Business discussions for later. Next, are you using any digital tools to manage water consumption? It's a yes or no question. So the great average at the moment is leaning towards the no side. And only 2 respondents are actually using any digital tools. It's still not something that is very developed and spread across the consumers. So now we'll give the floor to my co-chair Juan to move on to the second part of the presentation. Yeah, it's just,
There's no
this
presentation
is just a
myself.
fact.
It's just a set of questions to have your answer before listening to the pilot. So we have your answers before and after you have the information. So maybe that could change or give you some different idea.
Just want to go into full screen. Oh, yeah, there you go.
So the first one that is going to be related with a session that we are going to, not with a session, with the presentation that we are going to have just at the end of this today's session. So yes or no question, do you think it's important to involve consumers in the process in general, that they know about the water that they are using, how it's they are using it efficiently or not, and so results.
Show results
It was expected, this question. So yeah, we will go to the next one. I don't think nobody will answer differently. So your ideas now of brainstorming about how consumers can collaborate in the. let's see. It's different, isn't it? Okay. It's not a way to see all of them together. So we have sharing good practices, applications, the sharing again, raising awareness. Starting challenges on social media. Be open about suggestions, try new options. Yeah, I think that this one, probably the consumer will need some help about the suggestions and the options. Compare their consumption. Scheduling water use, discharge. Okay, a water city send forums, involvement of schools in the process, supply of tools consumers to monitor. Okay, we are having a lot of ideas, that's great. Having outreach and informational campaigns to highlight the limits of the water network and the need to improve consumption efficiency. Yeah. Provide water usage application to show how much water they use, campaign that.
Maybe if you can click, we can see.
Do you think, I have no idea where to click up to show all of them. That will be the menu? No. Oh, support officer activities to reach more people. Okay, awareness, my information of the. Yeah. So yeah, we have.
If you click on the arrow to.
I think if I go to the others, we go back, or if we move to the next question.
Okay.
Yeah. So yeah, it's a pity I don't know how to see all of them together. But just to get an idea, I think that the awareness and sharing information were one of the most repeated ones. And providing information to the consumers is going to be helpful too. So I think I'm going to move to the next one, and then we will see what we have after the presentation. So which water management elements or processes you think should be improved? Yeah, it is for brainstorming to know which ones you think.
Because there is an option in there. There are two options in there.
Oh, really?
It
should.
There is like a note that with A, what it would be.
Okay.
On time.
Yeah, it should have been an open question. Okay, we have some questions related with the previous ones, that the involvement of users in the process should be improved. We have the improvement of urban watering, also two of them in agriculture and in industry, water recycling, that should be also improved. Reducing fossil fuel for usage for watering and water quality and assurance. Yeah, I think that we are pinpointing most of the elements. I think it looks like yeah, most part of or most elements should be improved. Okay. I don't think that we are going to have any other, but yeah, it's quite interesting.
Just
Um,
try to add it.
okay.
Management, but I could put it in.
Sorry, asset management. Yeah. That's also a good one. And I think this one should be the final question before moving to the next section. So what are the main barriers to adopt this kind of smart water management strategy? Yeah, to apply a digital solution.
It's really.
Don't pay attention to the scale rule.
Yeah.
It should be an open question also. So we have from the lack of awareness from the users and some related with the cost of implementing some kind of solutions that needs financial support. All the infrastructures that it will mean that a lot of efforts for all infrastructure to be capable to be digitalized. Okay, yeah, standards and directives, lack of education, budget again. Okay, and bringing more cities and utility companies into the program. So yeah, I think that we get an idea of what is lacking and what's the user, the end user role in this type of solutions, or what is your idea right now? I think that we can move to the presentation, so maybe afterwards we can collect some useful information. So, do you have any? Okay, so now the first pilot from from the Nayades project, Ignacio Casals will do the presentation. Go ahead.
Hi, I'm Ignacio Casals. I'm the Research of Development Manager of Aguas de Alicante, which is the utility managing the urban water cycle in the city of Alicante in Spain. First of all, I'll try to present this afternoon the use cases we have implemented with on the platform of Nayades in the city of Alicante. And to begin with, I would like to devote just one slide to tell you about the context of Alicante, which is very important to understand the importance itself of the use cases we have selected and the rationale behind them. Well, Alicante is a city in the Mediterranean coast of Spain, in the southeast, which is classified as semi-arid. Actually, it only rains something like 200 to 300 millimeters per year. And it's very irregular. It can get to rain 200 millimeters in just one day. So this is really complicated in order to make use of the hydraulic resources. Actually, there are no local surface water resources. And besides that, the profile of water demand is concentrating and increasing in the coast. And there is also a strong peak seasonal demand in summer because it's a partially touristic city. So for all of this, the water use is an important piece of our strategy for the sustainability of hydraulic resources, together with the efficient use of water and with water savings. So in this context, if we see, actually this are all the use cases in Nayares along the urban water cycle, and we can see that from water production to distribution, water use, wastewater collection, and wastewater treatment and reuse, we have actually implemented several use cases. If we focus on those which have been implemented in Alicante, what we have is something like this. So it's what I will be explaining very quickly this afternoon. We have selected demand forecast for production planning, municipal water consumption dashboard focus on the consumption and the usage aspect, and saline infiltration detection, which is critical for water reuse. So let's see the first of them. The first of them is the water demand forecast. In this use case, we actually have two different applications. The first one is what we call the short-term forecast, which is the prediction of consumption for between 1 day and 1 week. This is mostly for operational purposes, for the optimization of water production to avoid excessive energy costs and also to avoid extended periods of storage of water, which is water quality. Obviously, we intend to fulfill the water demand of the city and to assure water quality, as I said, avoiding excessive storage periods. For this, we are using as data sources the history records and also the present information of the control meters which are already available in our SCADA system, and also the weather forecast produced by Nayares. Then on the other hand, we have what we call the medium and long time forecast, which is between 1 month and 1 year. In this case, the objective is more related to planification, to the management of hydraulic resources, to the sustainable management of resources. It's also related to economic aspects such as the purchase of water, because in Alicante we are both producing water and purchasing treated water, and on the financial planning of the company. For this, we are using once again the history records of the control water meters present in the SCADA. And this is how the platform looks like. In this fashion, we have for instance, here we see the short-term forecast, and we do not only have the forecast itself, but we also have the higher and the medium forecast, which is interesting to know, which is the expected higher and lower potential consumption for the next days. So we have the evolution is also available for different sectors of the city. So we have this information can be split down into several sectors. And something interesting is that we can also identify the deviation from the predicted sector or zone demand by comparing the forecast with the real-time consumption, and that gives an indication on abnormal consumption which could be caused by leaks in these sectors which have an abnormal consumption, abnormal demand. So for the second use case, which is saline infiltration in sewers, as I've said, this is strongly related to water reuse. The reason is that, in most coastal cities, and it's exactly the case in Alicante, saline intrusion of the phreatic water into the sewerage amounts to 12% of the water that gets to the wastewater treatment plant. And the problem is that salinity cannot be removed by the conventional wastewater treatment processes. As high conductivity prevents water reuse, water with saline content cannot be used for irrigation. We need an additional desalination treatment. Actually, in Alicante, we have a desalination plant for wastewater reuse. that increases the energy cost of wastewater treatment. So considering the energy cost of the conventional wastewater treatment and also the additional costs for desalination, for water recycling, we get to the huge amount of 1 million euros only associated to the excessive cost of treatment in the wastewater treatment plants of Alicante due to the infiltration. So for this, we implemented this tool which is intended to detect and locate saline intrusion by means of sensors for flow and conductivity, combined with anomaly detection algorithms and a decision support intelligence. So as you see here, we have we have the raw signals. We obviously can see the conductivity and the water level for all the sensors installed, but the most important part is the one below, because the system is able to compare the information from the different sensors. So it's not analyzing only sensor per sensor, but it's comparing the information from the different sensors installed and give us information on where the potential infiltration area, where the infiltration has been caused. And it also gives us comprehensive information on the potential infiltration, allowing us to locate it quickly and repair it. And then the last use case for Alicante is what we have called the municipal water consumption dashboard. In Alicante, actually in Spain, municipal consumption accounts for 10% of the urban consumption. This means that there is a large potential for consumption reduction, because we know that it's not an efficient consumption in most cities in Spain. And even though most consumption points in Alicante are equipped with smart water meters, we have a problem. Is that the high number of consumption points, actually in Alicante, the municipality has more than 500 different consumption points, including schools, gardens, other facilities, means that actually the municipality is not able to perform this control. Furthermore, there are many factors involved in the interpretation of data. You should also be aware of the size of the garden. You should know the number of students at each school, and all of this is the only way to have meaningful information. So we also detected that there is need for awareness campaigns in this particular consumption. So for this, we implemented this use case using the IoT smart meters already existing in Alicante, and the information both of present consumption and historic record, and also the context information for each point, that is to say the garden surface, the number of students or the number of users at the different municipal buildings. We combine them in, first of all, a municipal water consumption dashboard that provides the consumption evolution, the normalized, the standardized consumption ranking per type. I mean, we have a ranking for gardens, a different ranking for schools, a different. With a map view, in summary, it gives a comprehensive insight and understanding of the consumption to the municipal operator. And then, as a kind of sub-use case, we also create a school awareness dashboard, which is using part of this information to share also the information, not only with the managers, but also with the students themselves. Let's see how it looks like. This is the municipal water consumption for the managers. They have the consumption analysis per category. They have the different consumption points. You probably cannot see, but there you have the schools, gardens, museums, sport facilities. So different a classification which is more or less meaningful. They can see in the map the high consumption points, the high consumption points per category once again. They can also have access to the detailed point consumption for each one, and that way they can see in just one glimpse how is consumption evolving in the city. As I said, we also used a subset of this information to create a school water awareness dashboard in which the schools have access to their own water consumption information, and they can also compare themselves with other schools in an anonymized way, and they can see how their consumption has evolved. They can check if it has been reduced or not, and actually we checked this in a context among schools in Alicante, and we got a reduction for those schools that had access to this information, as the students had this feedback on their water consumption. So this is the last slide. In summary, as you see, we have covered more or less of all the elements of the water cycle, of the urban water cycle. We have combined information from many different sources, from legacy sources, from IoT water meters, from context information, from weather forecast. We have also carried out very different kinds of analysis, some machine learning analysis, some anomaly detection algorithms, and also some conventional analysis of the water consumption, for instance. Well, I think that, yeah, this was all.
Now we can move back to the co-creation exercise.
Can I ask a question?
Yes, please.
I was wondering, so from a financial point of view, who's paying for the smart meters at the schools or the citizens?
Okay, yeah. Actually, in Alicante, right now we something like 85 of all these water meters of the city are already smart water meters, and because we started in 2012, and we have been replacing all the traditional water meters for smart water meters at a rate of 10% of the total amount per year. So we are supposed to finish this year, and it's paid by the tariff. It's paid by the water tariff, and they are radio smart water meters. They have a lifespan of at least 10 years. Well, it was a commitment of the city. Obviously, it makes sense because we have such a strong water scarcity in Alicante that this was a very important point. So, home consumers already have the access to the information of the smart water meters, and they can see the daily consumption and everything. But as I said, actually it was more and the city council could also see that, but they had 500 meters to query one by one. So we wanted to give this kind of a dashboard view. That's the difference. Okay, so first question for you. What do you think are the main barriers to boost water reuse in your city or in your area? I think that here you have to give a score to these different factors. Okay. Obviously, you are being honest. Lack of interest is the yeah. Yes, I'm sure it can be infrastructure cost. Obviously, this is also same thing as someone said, as it was said about the smart water meters. You have to pay for it, and you have to really be committed. and social reaction. This is something curious because it depends. It's strongly dependent of the awareness of the citizens, at least in my experience. Okay, there's a clear winner, which is the lack of interest. Yeah. I'm afraid as climate change evolves, we'll see this reduce. Okay, I think that we can leave it here. Okay, let's move to the next one. So, lack of interest and infrastructure cost. I agree with this completely. And now a question about the public water use efficiency in your municipality. Please pay attention with you talking about the public use, that is to say the use of water by the municipality, not that by the private customers. That is to say, maybe for irrigations, are they being efficient in their gardens or for their fountains, the whatever? Well, the average picture is not very good because we have if we add insufficient and catastrophic, we have a 6/8. So no one has considered it to be good. Yes, actually, I don't know how it is in your cities, but at least in Spain, the problem is that many cities either do not pay water at all, or they pay a reduced rate. I hope that maybe in your countries it's better, but that's the case in Spain. And they are not really interested in being efficient in their water use. Okay, no more answers. This was an easy one. Okay, and now you have many options to choose. What is your opinion about the use of IoT data to increase consumption awareness? Whoa! How many answers have we got? Okay, thank you. Much more interesting now. Okay, well, I think it's a balanced picture. Much more balanced now. Still, I guess that it's probably true. There are other tools that have also to be combined, but in any case, it is so obvious that at least most of you think that it is of some use. Maybe you do not agree in the degree of importance, but all of you consider, no one at least has considered that it makes no sense. Okay, so I don't know if we still have one more question for this. Let me just check, because I can't remember. Yeah, this is the last question related to this presentation, because this is something that we have actually dealt with at some times. We all have so much information about our health, our energy consumption, water consumption, whatever. So is there a risk? Is there a risk of intoxication also in water consumption applications? Okay, so how can we believe with our first question? It's make it relatable. It's a nice idea. Education, yes, I do thing. I understand that you mean oriented especially to the younger ones. A clear message, a focused message, a simple message always helps. Make it simple, clear and simple. Important message. Use schools and children to share the ideas. Yes. Once again, education, send very clear messages. Clearness once again. Limit communication, maximum 1 week, 1 per week, for example. I do agree with this. Promote simple, specific action in relation to this information we are providing, and don't spam. I like that one. Okay. So thank you for your participation. I don't think. Let me just check. Now this is for the next. Okay, is that for me? Okay, I did not remember this one, sincerely, honestly. To what extent can digitalization support the adaptation of the water cycle to climate change? Once again, what is the important words? What is the role of digitalization now in relation to the adaptation to climate change? Okay, at least someone considers that it can help only marginally, and someone else considering it's just 2 persons. I consider that it's just 1 or 2. Okay. And well, you are not extremely enthusiastic about it, but still you consider that it is a significant element. Fine. Okay. Okay, now this is definitely the one for Braille. We leave it here. Thank you so much.
So now I'll invite Julian to carry on with the presentations.
Hello everyone. I'm here today to talk to you about the challenges we faced at modernizing our water infrastructure over the last couple of years. I was hoping there would be more people, so that this information would be useful to somebody who's in our situation, who had a time of upheaval in the 90s when the infrastructure was sort of abandoned, but maybe it'll be useful to you as well. The Coupe du Nera, I should change the slide. From old to gold, the challenges of revitalizing aged water technology. So I work for the Coupe du Nera Braila company, which is short for a public utility company or Companie de Utilități Publice. It is based in the city of Braila. It's a city located on the Danube in the eastern part of Romania. It's a city that is a bit old. It's been around for a while. There's been people living there for a long time. It's actually quite difficult to do any sort of infrastructure work without accidentally digging up some Bronze Age relic, which is actually what we're seeing now. Those were dug up, some of them I believe, where the new bridge connecting the Dobroja region to the rest of Romania is being built. So it's a place that has had some history, and because of this, it sort of has expanded its water infrastructure as it needed over the course of time, and maybe not always in the best of ways. Our company operates around 2,000 kilometers of pipes and nearly 700 kilometers of sewer lines, both in the city and in the county in general. And we're sort of running into issues with this network. Some of it is a bit old, some of it is a bit outdated, and the best way to solve everything would be, of course, to just replace every bit of old pipe and replace every bit of old technology and just leave it at that. But that would take a lot of money and would take a lot of, well, everything. So even though this would be the ideal solution, it's not available to us, especially since we have a very, very important historic center with very old buildings in our city that cannot be modified. They are quite possibly fragile at this point and should not be affected by all sorts of digging, which we have to do a lot. So with that stage set, I actually want to pose to you some questions. If I can see, yes, this one. So how modern would you rate the infrastructure of your city, your water infrastructure? So let's show results. Well, it's good to know that at least somebody is still putting the old Roman aqueducts to good use. Very happy to see that. Also, again, this was a talk directed mostly at people who would have not fairly modern as the majority of its infrastructure. But again, I hope that some of the challenges we faced are relevant to you as well. So let's go back. Actually, no, there's one more question. How advanced would you rate the management methods of your water system? As you can have a fairly modern piece of infrastructure, but the management that is still set in the olden ways. So let's look at the results. That was actually very balanced. So yeah, needing improvement, entire needing improvement, somewhat advanced, basic. At least nobody's claiming to be the most advanced possible. So there's room to grow for everybody, it seems. This is a good thing. This is a very good thing. I'm going to leave you a couple of seconds more to vote. And we'll get to the next part. All right. The main way through which we've decided to actually implement renewal in our city to improve the infrastructure and the management and technology in general was through implementing district meter areas. They are areas that have been sectioned off from the main network and sort of turned into their own mini network where everything is more easily controlled, more easily monitored, and where everything is catered to the conditions of the network itself. If there are issues where pressure can be too high because of old pipes or because of surrounding buildings, then we keep pressure in that area low, for example. The establishment of these sectors, however, has been a challenge unto itself. The first challenges were administrative in nature. There's the issue that actually sectioning off parts of the network and adding new junctions and new lines and cutting off some old pipes would require us to dig, and digging again is something that we can only do in limited situations when we're dealing with the old parts of the city. And there's also the problem that in order to have roadworks, we do need close collaboration with the city itself to get approval. And something that we have done as best we can in tandem with the scheduled road maintenance. And it's been a slow process, but we are getting there, and it's coming along. Now, to actually do that, to actually make DMAs, we first need to know what the network looks like. We need an understanding of the topology, and for that we have set up a geographical information system, or GIS. We've basically digitalized all the old records and integrated all the as-built files received from contractors over the course of time. Unfortunately, some of that data was imprecise, so it's taken us a couple of years to actually piece everything together and get things in order. A major lesson we learned from the GIS side of things is that you can't really do this kind of work with a limited number of people. You need multiple teams capable of going to the field and making measurements and integrating data in basically every point of the county all at once, sometimes it seems. So we need more people. That's one of the issues. Also, those people need to be supported by proper tools. On the hardware side, the sky's the limit, and the good tools can be quite expensive. But on the software side, it's actually surprising how cheap things can be. I mean, free. Take, for example, QGIS. That is a free and open source piece of software that is incredibly configurable and can do just about anything that most much more expensive pieces of software can do. Alongside PostgreSQL, which is a free database agent with the PostGIS extension, it can lower your software costs for implementing a geographical information system to zero. There is, however, one snag. You're going to need a programmer to configure things and build everything to your needs. Otherwise, you will have some struggling along the way. But it's not that impossible to achieve. And it may seem obvious to you since you're at IoT Week 2022, but in our corner of the world, the idea of having an in-house programmer at a water utility isn't really mainstream yet. And keeping them around can be a bit of an issue since we're a public entity and can't really compete in terms of benefits with private entities. Now, the second thing you need in order to set up a DMA is to actually have a hydraulic model. And this lets you know how the network behaves. You can go on cutting pipes that will actually be needed later on. So it's important to have a system through which you know precisely how your system behaves. And you can only build that after you have really well put together GIS data. Without that, again, you don't know where the pipes are. And you also need modeling data. You need behavior data for your network. And getting that can be a bit tricky at first. That's why we sort of set up proto-DMAs instead of having final regions that we can call a DMA. We've set up larger regions, we've monitored them, and then we'll section those off subsequently until we reach what we call a final shape. An area that can be properly monitored with fine-grained detail without much issues. In terms of software, on the hydraulic modeling side, EPANET is the foundation of basically every piece of modeling software there is in this field. You also have a plethora of very amazingly useful tools that are also based in part on EPANET. And going back to QGIS, there's extensions for it like GIS Water, which can simply use it to generate a hydraulic model with EPANET in the background for data calculation. The upside to this is that when you modify the model, you don't have to re-import if you add pipes in your GIS, you don't have to re-import the model into a different software. It all works directly from QGIS through the extension. And all of this is, again, free, but you do need people to configure them and get them to work properly. And also you need data, a lot of data, and I mean a whole lot of calibration data. And for that you have SCADA, which is a fancy way of saying supervisory control and data acquisition. Pardon, I got things mixed up. Supervisory control and data acquisition is a fancy way of saying that you can see what's happening over there and control it from way over here. Implementing this can be expensive. It's probably one of the most expensive things we've done, and it will be time-consuming and require a lot of work. But it won't be just used for the modeling part of the system. SCADA is used for supervising and controlling all the very complicated equipment and machinery needed to properly handle the task of purifying water and dealing with everything that needs to be dealt with in a water utility and wastewater utility company. And alongside all those machineries, all those pieces of equipment that need very, very fine control, you can also add the data from your flow sensors that tell you how much water is going into a DMA and how much is going out. You can add pressure sensors to know what's going on. You can integrate the consumer side smart meters if you have those. You can integrate even noise sensors, which will be quite useful at detecting leaks. And it's not enough to just collect that data and have it bulk stored somewhere in a database. Now you have to process it, you have to digest it, compute it into whatever form you see fit so that you can extract actionable information from it, which will help you optimize the system. Apart from needing in-house programmers, probably several of them to develop your SCADA system, you also have to develop your information network. Now, some people will see this as an optional challenge, but I can tell you from our experience that it is vital to have your own telecommunication infrastructure. Depending on somebody else's communication infrastructure just opens you up to a lot of risk. You don't really know what's going on if you're using somebody else's network equipment. If they have some issues with their lines being severed and you're not being informed, you will be up in the air. So it's important that you set up your own fiber optics your own radio relays where you can, and your own network equipment. This is also important because of the Network and Infrastructure Security Directive, which obligates us to put security first. If your network is completely independent from somebody else, then you have a leg up on security, and that is very important. In our case, we have a SCADA system that, when it was first developed, was pinging, was monitoring around 10,000 parameters every 5 seconds. Now it's expanded to over 20,000 parameters, again, every 5 seconds, and soon, with the development that is being now put into practice, it will reach around 40,000 parameters being tracked within the next 5 years, again, every 5 seconds. We want that granularity because it allows us to see things much more clearly. It does, however, put a lot of a drain on the resources. It's also important to learn that water utility is an essential component of a community. So when you're talking about things like 5 years, that's still nothing. You can't think in terms of a quarter or in terms of a year. Decisions that you take now will have consequences for a very long time and for a lot of people. You need to frame things in terms of decades, maybe even centuries, or in the case of remote aqueducts, millennia. Eventually, you will actually get to the point where you decide that, or you realize that SCADA, hydraulic modeling, and GIS aren't different things. They're the same thing. They're actionable. They can generate actionable data. They are information that you will want to integrate into the same place, into the same interface, have them all converge and become a data singularity. And when you have that, you can truly say that you have everything that you need to properly understand what your network is doing and how you can create the DMAs that you will then be able to exploit to create a more optimized network with less leaks, with fewer issues, with higher service quality. And it's the service quality part that actually is quite important because you need to get the public involved. Meeting customer demands in terms of pressure, service availability, and quality can be a challenge when dealing with older water infrastructure. And because of this, consumers may not see you as a partner in this, but more of a hindrance or even a nuisance. It's important to communicate with them constantly. It's important to have outreach programs to familiarize them with how the network functions, what its limitations are, and to highlight dire water issues and droughts, for example. It's important that they have a direct line to you so that they can air their grievances and maybe even give you feedback that is not visible from your telemetry. And especially if your city relies on public infrastructure, I mean, your water network is public infrastructure, you alone as a company can't really exert the pressure, the political and administrative pressure required to implement renewal at a grand scale, but the public can. So it's up to you to inform them about the needs of the network and of the community. So with that said, I'm going to pose 2 more questions to you. Let's see if I get it right this time. And I think I did. How well do your consumers or customers understand the challenges of delivering water services? Let's see. No understanding. Yes, that sounds familiar. Oh my God, we are kindred, truly. We are the same. That has to be the one thing that everybody has in common. And no answer. Yes. This is going fantastically. We also need to still work on the customer side of things, and we are making efforts in that direction. And hopefully we will have some results to show you at one point soon. Okay, moving on to the other question. How much do these hinder your path at modernizing? If you can list them in order or rank them in terms of importance. I see funding is an issue for a lot of people. Lack of personnel, yes, that is an important issue too. Outdated technology, that can be handled with time. Political influence is getting high up there. And the winner currently seems to be a lack of know-how. Can insufficient funding pull through and win by a nose? Place your bets. And yes, insufficient funding is up in the lead. And I think that's the winner. So insufficient funding, lack of personnel, political influence, unavailability of resources, and outdated technology. That's exactly what everybody seems to be facing, mostly in that order. But you will see that with limited resources and very, very limited resources actually, you can do a lot, which is the part we're getting to right now. Getting back to this. So, over the years, we've tried to implement everything I've just said, and we have seen some results. After installing all those sensors and setting up all those systems, we've managed to get some what can be called actionable data. This is a SCADA interface, one of the many that we have in our system. This one is for the Rado Negru DMA, which is in the NIADAS project. What you're seeing on the background right now with the red square around it, that is a leak. That is a pressure drop that was detected on Christmas Eve, which not only told us that there was a leak, but because we have a bunch of pressure sensors in that area, we actually knew exactly where it was placed. So we managed to fix it within a couple of hours. It mostly took longer to dig it up than we actually detected. This was a fortunate incident because it was a big leak, so we were able to see it quite quickly with the sensor that we have now installed. Were it a smaller leak, we would have needed either more sensors or more sophisticated systems behind doing all the calculations to tell us that, hey, there's an anomaly there, which is why we're working on different things. This is a SCADA interface that relates to flow. It measures all the inflow and the outflow of the city at all its major points. And whenever there's a variation between today and the day before, we sort of get an inkling that maybe there's something wrong, as you can see in the pits that are encircled. Those represent leaks that took place and that we had to investigate and find where they were. This is something we'll be expanding to each DMA individually, so they all have this kind of data that is visually, that can be visually analyzed by the operators that are in the dispatch at that time. Again, this can be built upon. We can add alerts to them. We can even add some more systems to them, as I'll show you in a bit. And this is the systems we've built to handle the data we're getting from our noise sensors. The pictures you're seeing are both from the GIS system and from the SCADA system as well. And the GIS system allows us to see them on the map and give them to field teams, and they will go on and search from door to door if they need to find the exact point of the leak. And the portion that we have in the SCADA system will allow us to interpolate the results and have maybe some more exact pinpointing location, a more pinpointed location. All of this stuff has actually led us to be able to reduce losses in the last couple of years by some interesting percentage. In the Rado Negru DMA alone, we found a few leaks that accounted for as much as 60 cubic meters of water loss per day, and we managed to repair them. Those were leaks that were running in some cases for years. They were undetected. They were undetectable since all the water was not coming to the surface. It was just going down through ruptured sewer lines and washing out into the station that cleans the water and then dumps it out into the Danube. This allowed us not only to save water, but because we reduced all that waste, our pumps did not needlessly function, so we saved on energy. The surrounding soil in the area was saved and didn't erode, and no foundations collapsed. And the quality of the service also increased because pressure was no longer lower than people expected, and there were fewer complaints. all this translated into less money wasted and happier customers. This is just the beginning though, because through the NIADS project, we will have access to AI systems. And the one that we've mainly helped develop was the one that is capable of giving us better feedback at leak detection. For example, the component that deals with sound, with noise, will be able to give us more of a precise positioning of the sensors, so it will tell us where we can place them properly to get the maximum result possible for the number of sensors we have. So we don't, again, ideally, if funding was not an issue, we'd place a sensor everywhere, but that's not possible. So that 2% number is probably where we draw the line. But with this, we can achieve better results than we can by doing manual labor, manual calculations. Also, there is the system that is capable of detecting leaks based on pressure, which does require a functional hydraulic model to function, and will use pressure variation to indicate where leaks have potentially taken place. And it can do so probably, we hope, faster than what our operators can do when they visually notice that there's a pressure drop or when one of the alarms we set goes off. It's a very interesting future. It's filled with all sorts of technical solutions that can improve many aspects of a water utility. Many of them you would have seen today if the event were not so quiet. I mean, over the years we had all sorts of suggestions brought to our company, including one that used space-based satellite microwave detector. It shot microwaves at the Earth, and it calculated a reaction that chlorine water causes in soil, and that way it could detect leaks, possible leaks. Technology is fantastic, but the challenge we faced mostly is that of finding the right people. People who are passionate about the water sector, people who are willing to put in the work needed to improve it as much as possible. And when you have those people, you can develop a plethora of tools and solutions that can provide exponential benefits. But without those people, the solutions mean absolutely zero. At least that's been our experience. So I'd like to give you now one more question. I missed the mouse. Should I press escape? There it is. Okay, final question. What tools or solutions do you consider as being more important to modernizing your infrastructure? Let's see what wins this time. Smart metering in people, AI systems, hydraulic modeling, SCADA. I think you're noticing that this is a trick question. You need most of these or all of these. But hopefully, at the end of this portion, with the answers you've given, you've formed in your mind a visual hierarchy of what your needs are to improve your own water system. Where can you start? What's the things you need to focus on? What are your weaknesses? What needs to be strengthened? And hopefully this will be useful to you if you try to improve your water system and your water management and update your technology. So thank you, everybody. And this has been my presentation.
I'm just curious. So, developing technologies, as you were mentioning, the importance of having your own communication system. This because water utilities, they are such a crucial infrastructural point, and with the technologies being developed, there is also always a possibility of hacker invasion or
that
whatever.
is very high risk, especially now.
Yeah.
So we're actively being targeted.
Oh.
Thankfully, we have measures in place to deal with that.
Okay. Yeah. Yeah, because it's an important aspect.
It's important. We didn't develop our own telecommunication infrastructure because of the high cost initially, but a decade down the line, the costs would have not been that high. So going forward, we will move towards that direction.
May I add for an add-on question? Even though that you're not an expert in telecommunication, do you think that you will be able to set up completely yourself?
Well, we've started doing that already. We have networks that are completely enclosed using radio relays. We've linked stations that we basically could not find a carrier capable of giving us access to the infrastructure in that area, and we set up our own radio relays. We use the micro-thick antennas, put them up on the biggest poles we have access to, and just have them communicate between themselves. All the data is encrypted, everything functions perfectly.
Okay.
That's a distance, I think, of 1 or 2 kilometers. I think we have one that goes a bit longer distance, but it does have some data loss from time to time.
Okay. Do we have time for one more question?
Please.
Yeah. Have you implemented or are you considering any other asset management tool? I mean, besides GIS, for example, decision support system for network renewal or for network, because I mean, you have this so very old network, but you're just trying to repair, obviously, but I guess that at least you will have, even if it's very small, you will have a budget for renewal, so it's so important to select the best pipes to replace.
Yeah, we do have in our company, thankfully, we have a system that keeps track of what pipes are in what stage of decay and which ones need to be replaced. But it's a matter of getting the funding to do that, since this is public infrastructure. We don't own those pipes, we just maintain them, so that's an issue for us. Digging them up again is an issue because in permits we will cause untold havoc on the traffic in the area whenever we dig up a pipe, because you have to close off roads. And it's a complete nightmare for everybody in the city whenever we have to do that. So we do it as finally as possible.
Yeah, but sooner or later,
We'll have to replace everything at one point.
it's a matter of time. Repairing leaks, it's only giving you some time, but
Yeah. At some point, somebody out there is going to have to commit political suicide and say, let's replace everything, and nobody will ever be able to drive a car in that city for a year or two.
yeah, probably.
Okay, I think that the earlier case was very interesting. We have many questions and good discussion. Now I'll move to the city of Garous. I'm Euna Kim. I'm presenting the Garous case on the behalf of the Mr. Maurizio Lossi, the city officer who take charge of this part of the city infrastructure of the Garous, and the UDG Alliance is the technical partner of the city of Garous, and then of course also the IoT platform builder. But today I'm only talking about the city's perspective on behalf of Maurizio. Yeah, you see that the two cities cases as a water utility management perspective, which is a very common cases of the urban water management. Today, the city of Garous will give you the different perspective of the urban water problem. As you know, Switzerland is a rather rich country, and so that we so maybe it sounds like a little bit of this problem is a bit the rich one, but I would like to emphasize that every city should work on the sustainable water management, and we, the city of Garous, want to make the city greener and more sustainable. So the city council played quite a bit of the effort on that. So I will introduce you on that. The city of Garus is located in the Canton Geneva in the western Switzerland. It's a global financial center, and then this is a very fast-growing population. It's the city of Geneva is the central one, and then this is the suburb city, and it's just directly connected to Geneva, and then this is the population is growing and the cities are growing, but this very typical problem that we have is that actually the city's budget is not that fastly growing. So we want to save some water, and not only the money side, but this is really the city want to have a biodiversity and the sustainable city movement. And Switzerland, we have a country-wise of the this movement that they select the city of the energy, so that the Garus actually got the word on it, and also Garus is known as a fair trade town center. But the city council still strongly want to move on the sustainable way, and city of Garus has a bit different situation than the Alicante and Brailia, that we have a public water management company. It's not directly linked to the city, but the whole canton level, so that the city itself doesn't have any control on the water utility companies. So city is a consumer, and of course, but to manage the city, we need a lot of water also. So in that sense, we want to make it efficient, and also that the threat of the climate change in Switzerland is when I moved to the Switzerland, I think it was first visit of Switzerland was 2005, and then that time I visited the glacier part, and then time to time I have visitors from other countries, and then I brought them there, and then I clearly see the level of the glacier shrinking. And then that's the climate change you could just directly see from your eyes on the side. So we really want to tackling the things on this side. So City of Garus found the two use cases. One is the Garus has a whole around the city. We have a flower beds and then city gardens. The Garus really want to have this blooming city, and then actually had some award, and then even 2021 also got the award as a blooming city, which is awarded by the canton. And we have 180 flower beds and then green areas. But the thing is, we give the water by the electric trucks. I think I have another picture there. Yeah, so that the city, the workers, gardeners take care of the garden, and then they manually give this water that the one plant pot by the other ones to give the water. But so far it was just manually by the city gardeners. See that if it's twice a week, or sometimes it's more, just manually just go, or sometimes it's just on the day it's rainy, then it's a stop, but they do not have this kind of the efficient management part. So it's not only the waste of water, but also you need a lot of labor. And then city actually searched for the solutions. There was a commercial solutions, but the problem was that they want to sell just the whole set of what they have. So it's a fear on this band lock-in problem. One city want to add something more, but it was not so easy. So this and also want to influence this by the knowledge of the gardeners, because they are very professional, more than 20-30 years of the experience, but it was not ongoing that direction. And then also city had different parts that we also participate in synchronicity, the smart city one, but any data interoperability was not provided from the vendors we checked. So that's how we wanted to get help from the NIADS project. There was the one requirement, and then second one was the water quality management in the fountains. These fountains, I think that here the NIDA's partners visited the place. This is not just the fountains, but it's a wetland pool. So that I don't know if they clearly show there, but if you see that the other side of the picture, you see the kids are just running around. This water is like your knee side, and then so summertime the citizens enjoyed, and then kids are swimming and then playing in water. So this is directly related to the water quality problem. So when the water goes bad, then it can impact on the citizens' health or who play there, so that they have to drain the water, and this was not the good way to handling things. So that also the city want to have an early detection of such cases, abnormal cases, and also want to react quickly to by the decision support system. So such things, and the water quality prediction, so that we have AI, and then also there's one more thing is this chlorate or bacteria things we want to measure, but there is no such a sensor out there. So that the project built the sensor and an AI system to use this, and then also on top of the distance support system, and then this is the we believe that this way that we could improve the efficiency and also the not only the water but the whole management part. So I just focusing on these two problems because I think that the morning sessions we talk about all the solutions, so I do not want to repeat it. So that the NIADIS is helping to solve these two problems of the cities. On this edge cloud side, that we aggregate data and then make the data interoperable and also modular. So what city wants that we add it. And also, of course, it's not only just for city of Garouche. So for the more scalable and then sustainable co-development, so that this solution support, of course, also Borrelia and then Alicante at the same time. So in a city's point of view, cities continue to work on the sustainable city development. So that the water is one of the best, the most important natural resource, so that they want to make a more effort on that. And then also these two use cases are tackling the currently the urban heat islands problem, so that not like a suburb area of a lot of greens, urban side of the living style have a less greens and then concrete and buildings, and then if you measure the temperature in the center of the city, it's really hugely different from the suburb side. So what cities are doing with these kind of two use cases is not only the water, the efficiency part, but also want to see tackle the urban heat islands problem during the summer times. I think that these kind of problems for other cities also it's very important to tackle, so that the want to show in that direction. So the more importantly, we said that for the scalable growing, the data interoperability is very important. So we want to move forward with in this direction, and then glad that the NIADIS is helping this. This is my brief presentation, so that I don't make you feel so bored after lunch. I think it's when it goes long, and then this is quite hard to focus. I think this is like a borderline to be quite bored. So let's move on to the slide. Okay, so that the first question could be we collect your opinions. So from which area of society you think that the most interesting and potentially effective smart home solution, sustainability ideas coming from. So please choose your answer. By the way, this is a multiple choice, so you can choose the multiple things. Okay, let's see what kind of answers we have. Okay. So we have, wow, that's the quite of the bit of the big portion is the citizen science and the vet labs. Okay, it's interesting to see, and also civil society and the industry is also takes an important role. Then we go to the next question. So what are the main obstacles for smart water solutions to go from the initial ideas to concrete and sustainable deployment on the field? Okay. So let's see the result. Okay, so now we see the constraints to update the Lego systems and the financing. Two are the big parts that we think it's obstacles. Okay, now I move. Well, that's interesting. The technical know-how is already there, and then we just need the technical the financing part, and then maybe we have to push. Oops. The next one is which one of the following expected benefits provided by a CD scale watering optimism system would you consider as the most important? Okay. Yeah, the current city's point of view that they want to tackle the citizens' well-being and of course the water saving and labor reduction, and then now it's more on the fundamental problem, the water saving. I think that's the winner. Oh, now it's the improvement to see. Oh no, now with my comments, somebody put it to there. So yes, oops. Yeah, so I mentioned this is the two the problems the city of Garuz is tackling is the related urban heat islands problem. So that do you know any other projects that could help or tackle these same issues during the summertime due to the climate change? We see that many of the utility problems and things, but I think this is also quite interesting things. There are when we talk about the sustainable water management, I think that when you could handle your cities and making effort to reduce these urban heat islands, I think that is also I think it will help to make your city more sustainable. To grow. Let's see, show the result. Okay, so Barcelona has Euro-funded urban innovation actions and then tackling such things. That's quite nice to know. Planting trees, more shade by planting trees. More trees, okay. Green walls. The new type of paint was reduced. Oh, okay. Okay, developed to. It reflects the 99.9% of light. This is the good to know. Climate impetus. I think also not only the Garage and the Switzerland, the many of the cities and then communities, they actually have a quite big, large green areas are subsidized by the government to keep the green areas in the cities also. I think that this is my one. Is this my one? I'm sorry. How this is impacting your own area, city? Yeah, both. Yeah. Both garage use case can be seen as a potential answer to increasing issues of. No, this was the previous one. I don't know why. The urban heat islands during the summer times due to the climate change. I think. Yeah, this is the impacting of the city. Yes, the two things. So please the mark that the scale that if it's impacting in your city.
Which one is the first one and which is the second?
I think this was the one, but somehow I think it comes to two in this slide. So it's it's a one scale, but you can just mark it both. I think that was the one scale. Okay, so I think the many see that we see that quite in average that they see that the impact on the sort of the slightly impact on site. I think that's all my questions. I think. Yeah, this was not fine. Okay. Okay, thank you very much. If you have any other questions, I believe none. It was clear, but if you have anything, and please, visit me later, and then I will be here until the evening. Thank you.
So I think now it's time for Aitor to present. Yeah, if you're.
Yes.
Yeah, it is. So, yeah, the floor is yours.
So, I'm Aitor, I'm from Eurocast, most of you know me. I'm a senior researcher on that organization, but I am also part of the ICT for Water Cluster and other associations related to water and standardization. And what we are talking about, we are talking about we're digging into the jungle, into the standardization story that's coming from long time and is continuing still there. We will talk about a little bit just one of my favorites, senior stars, but the importance of standardization in the water sector, just to dig into how many standards there are more related with physical and digital part, but also just to finalize with some small remarks on that matter. So, why is important the standardization? Yes, it is not only just to establish norms, but itself not for pushing to introduce some technologies into water market, but it's also to, for example, to ensure responsible management of water use. And in fact, also when we are talking about increasing water scarcity, when we are talking that cities every day are increasing, that they force newer or larger water demands, and well, we need to ensure that precious water should be efficiently used in the city. We are also need to talk about ensure a secure, safe operation. These operational aspects are really important in the infrastructure, not only for digital part, but also for the physical ones. We has been here talking about modernization of the water infrastructure. We has been here talking about how the water cycle, the different challenges of the different water value chains just from the not from the caption, but also for the water supply, the treatment, purification, distribution. We need to ensure water quality around the cities. We need to ensure also water security in the cities and in the entire infrastructure. So we also need to interlink water with other infrastructure, and for that the best time is just, or the best things are to establish common architectures, common points, just to ensure or to share experiences, to share operational decision making, managerial decision making, and at the end to promote and foster knowledge exchange between water and other integrated infrastructures, for example, energy. And here in the picture we can see that both the infrastructure they have similarities in terms of network, but also there are a huge potential just to share the subsequent decision-making procedures. What else? We need to engage stakeholders. We need to engage the communities. We need to ensure that the society are part of the water infrastructure, just not only just to put it a bit on there or to enforce them to reuse water, but also to ensure them that they are part of newer modernization and newer water business model. That well, there is a term that is called water smart society. That is one nowadays is forefront since the beginning, and then we need to that the stakeholders be a key part of the water infrastructure. But at the end of these challenges, of these needs, a lot of associations, a lot of standardization bodies are playing the game, and well, we are in a jungle. We pass on the story just for private standards that creating some vendor locking on the water domain as others. The result was just to create silos on the water infrastructure that well, generates not a lack of knowledge, holistic knowledge inside the water infrastructure, and we are not talking about the lack of knowledge about the correlation with other infrastructures. But this was more open-minded, and the water sector was evolved until the adoption of open standards driven by the community, driven by the market, and also under the topic of Alberto's, and that is a member of FIWARE, words here, is just to moving towards an agile standardization that is more focused on the business aspect rather than pushing things by enforce the entire market. So at the end, what are we dealing with, and specifically in ICT, IoT, in water sector? Well, we are facing about using Sareb ontologies just to share data, just to put a common vocabulary, just not only to represent water sector, but also to interlink with relevant infrastructures. Under Sareb, under the umbrella of Sareb, there are a lot of key infrastructure as energy, as water, health, transport, building, and the environment. There is still work to be performed. There is a need for maintaining, for updating, for complementing these ontologies that well, we could be a great asset for ICT guys just to share data across infrastructure. This ontology, as I saw in the right, your right part, is just about meters. It talks about infrastructure. It talks about sensors. It talks about different waters, different water value exchanges, and then it will be not only make or remove the silos of the barriers of the informational barriers of the water sector, but also just to establish bridges with the rest of the infrastructure. And as a piece of software that it would be nice to be mentioned is just the context broker of FIWARE that has been adopted as a tool to integrate data, to put in an open API and a REST open API all the information of the smart data models that interlink with Sareb concepts and generates, well, a way just to share this information. Also, the great benefit of this context protocol is that it is a small piece of a huge digital environment that is called Firework. And, well, we open the door just to share AI-driven models, to share visualizations tools, and to share, as another example, plugins just to integrate data across a big community. So it is a great effort that we don't to reinvent the wheel, not only in research projects but also on industries, just to share, to integrate data, to put into a digital architecture AI-driven models, and at the end to manage operational and managerial aspects of the water infrastructure. So, what are we talking about during the presentation? Just regarding the jungle, the standardization, we have it, the different water value chains, we have it, the different digital tools, a way just to integrate the data, to put the data, but also, well, there is still work just for moving or paying attention on water quality, water footprinting, hydrometry, drinking water, wastewater, irrigation, infrastructure, modernization of the water infrastructure, but not by least measuring the different water flows, and just at the end to enable strategies by the way of common technologies, standard technologies, standard methods, procedures, water quality measurements, just to reuse water and make efficient also the water infrastructure. Just at the end, and just to finalize with a small presentation, that just not to bore you, is just a key message, just that standard provides solutions to ensure water efficiency, water quality harmonization, safety, transparency, and sustainability. But not only that it brings accessibility to standards and contributes to a wider adoption to the generation of newer business models that will be the next step on digital business models on the water sector. So, thank you very much for allowing me to explain to you here this, and if you have questions, just ask me. There is a questions. So, based on the presentation, yes, we will play a little game and questions about, for example, how important is it in your organization to use standards? Do you use standards in your organization? It is important for you? Yes. See, a little bit. So for most of the people, that is very important just to, well, the standards in their organization. Well, I expected this answer more or less, because standards create rules, let me say rules in between commas, just to elaborate and to establish procedures, establish robust procedures just to allow operational and managerial aspects. So this is really nice to see that the standards are still being important, that people follow up some specific common procedures. So as a next is, how many standards are you applying into your organization, more or less? In overall, we not be too exactly. Well, more than 5. People say more than 5. People say 2, between 2 and 4. Well, it is good to see, because it also correlates with importance. That is very important. There are several standards installed in the organization, so it is expected to be somehow, why not more, but to take more relevance over the companies. So just passing to the next one. What words come to your mind when we talk about standardization? It's quite tricky. let's see the results. Well, for now, no words. So. Scarcity. It's good. Well, the expected, a part of this is, well, is, well, there are some people say that it's tedious, regulatory body, long paper. European Commission, well, in the directives, the Eurocommission is behind most of the policies and also kind to push some standards. Despair, agreement, long paper. Problems. Well, more than problems, I think that is more that they create discussions and cumberstones in saying, well, terrible headaches just to implement it. For example, we are implementing some standards in our organization, like terrible to implement it. ICO, yeah, of course. So, and I have it one or two more. Do you implement some digital standards like NGSI, CIM, reference architecture like fireware, ontologies, and or other kind of data representation, data integration, data manipulation tools? Oh, I don't expect that question that so much people say yes. Well, because it's Nayades, no, right? But for the people that know, it's more standard today. There is no so much influence of this part that should be incrementing during day by day. And just one more or two more. How familiar are you in relation to data spaces? Do you know what that means? That is very familiar somehow, password, or haven't heard about any data space yet. Of course, there is a password that is for today, but over this aspect, there is a good concept that is being pursued just nowadays, data space or open data spaces or the domain, whether or the domain data spaces, for example, whether we are moving on water data spaces, just as a tool to share data between countries, just to deal with the legislation, regulatory aspects, just to enable the free flow of information. So in the coming years, it will be like a buzzword, but we expect us to be more realized in digital infrastructure. But for the people that there is no familiar, somehow familiar, well, there is over there a booth with ICA, that is the one organization that is moving on data spaces around the world, around Europe. So it could be nice just to take a visit to there. And for me, I think that's.
Okay. So, yeah, we are going to go to the final point of this conference. So, we are going to have the final discussion starting now. So, we have some general questions for concluding this session today. So, from what we have listened to during these presentations, I would like you first to rate the relevance of the digitalization in relation to the following challenges. It's still evolving, but I think that leaks is leading, followed by in this one, the colors are quite similar. Aging of the of the system. Yeah, water scarcity, I think, is in the third position, close by untreated wastewater discharges. Yeah, I think it's quite related with what we have seen during the presentation, and it looked like it's quite common among at least the present the people present in this room. So yeah, let's move to the next question. So, what will be the main drivers to improve the digitalization of the water cycle? So you have two possible options. Oh, you can select at least maximum two. Okay. It's interesting. And mainly because most of the solutions were more related with water demand and saving water, but the reducing the water quality risk is one of the most voted ones. And of course, reducing costs is quite important. I think that we have 4 of them that are considered the most important ones. I don't know if someone wants to comment anything about their answer, but it's quite instructive. So I'm going to move to the next one. So how much should water management solution rely on artificial intelligence? So you have 4 possible options. Okay, that's good from my side that as an artificial intelligence developer that nobody says that they are not useful at all. So I kind of agree with the answer with both of them. So I think that depending on the use case, one could be better than the other one, and I think that a combination of both it's always going to provide extra knowledge. So let's go ahead to the next one. So, which of the following digitalization concepts and related technologies do you know? And just let us know if you know any alternative to them.
Can I choose 3 or? No.
So are you missing any other concept that should be written there in the list?
I mean, the question is which of the following do you know? And then I want to choose them all, but I cannot.
It should provide the option too. So which one is the one that you know better?
Because all 3 that I'm working on, right? So.
Okay, so it looks like the first one is the standard, the fireware, as it is known by everybody, or by most of the people here. Okay, it's interesting. From Naya's project, it makes sense because we are based on fireware, but So I will ask the only one that I think is not from Nayades here. So did you know fiber before or?
I know all three of them.
All three of them. Okay, that's good. That's good. Okay. So next question: how important are the following water data handling processes? Okay, looks like data privacy and integrity. No, it has changed. Tuli is making is cheating. So it looks like that right now, yeah, the data integrity is leading as the most important. That be sure that the data has not been modified is it's quite important. Secondly, yeah, data privacy. So I think it will depend on the type of data. If you want the one that you can share and the one that you cannot. And finally, the data minimization. Yeah. For me, that one is also quite important because otherwise, in terms of resources to store all that data is going to be a problem. But yeah.
So as a researcher, you want to do data minimization.
As artificial intelligence.
Point of view, I want to see all the data that I can get.
But I want to have it reduce and remove the extra data that is not necessary for the.
But how do you know that it's not necessary?
The noise you usually can get rid of it, and so that's a pre-processing.
How do you decide that it's noise? If we are, for example, for our wastewater treatment systems, we are having random inputs. You don't know when it's going to rain, you don't know when people are taking showers, so it's random, so you don't know exactly when it's noise. And then also you have your sensors, you have pumps that are turning on and off on minutes basis sometimes. How do you decide that it's noise?
And some sensors already have a noise by themselves that they can be reduced by vibrations and everything that you can reduce with normal algorithms. You can have also the anomaly detections that can help you to reduce the amount of data that it could be useful to be stored. So I agree that you need to have all of it, but in terms of long-term handling data, it should be minimized so you don't end up just storing thousands of data that at the end is most of them probably are not useful.
If I can add to that, for instance, if we look at water consumption, for that we don't need a resolution of 5 seconds, we need a resolution maybe of an hour or half an hour. Maybe someone will disagree here, still, it depends what are you measuring at what kind of time interval not to over-measure because
that's from the point of view of that you have now in view of control system that you're setting up now. You know in 5 years we're going to come up with a control system to our optimization of our system that needs this minutes data. And then you're not going to have it historically because you didn't save it.
Yeah.
So I'm not talking from an operational point of view, I completely agree. From an operational point of view, I want to limit my data to what I need. From a research perspective, the more I get data I get, the better.
You can, like from my perspective, it's easier to do an overkill than you don't need. Yeah, I agree that like in future the technologies that we make even better adjustments, but then we still have to ask ourselves is this a technological solution or is a solution that's actually going to, be useful for people or for whatever use case?
Maybe coming back on your point of your water distribution, if you're going to look at peak consumption, which is important for your pumps, you're not going to want to know it over hour or days. You want to have it in minute scale because that's the reaction system of your distribution system.
Yeah, so it really depends on what the data is.
But you're collecting your data now at a certain point with this in mind. But in 1 year or 2 years, you might say, oh, we have a great new idea. I wish I had this data.
I can just comment also that data storage requires quite a lot of energy and resources. So at some point, this data minimization is balancing the potential need for the data in the future, which might also you might also be able to collect the data over 2 months, for example, or storing it for 5 years and requiring all the resources for keeping it up and packing it up and everything. So I think it's a balancing point.
Yeah, other issue related with that is how you select the. It is good to have a lot of data, but maybe the technology that will need more data in the future will also require other parameters that you will not be collecting. So at the end, all that information that you have collecting, extra information that you have collected, is not going to be useful. I say that because in many projects where we have previous projects where we store data and we have a new solution, but it depends on another parameters that we didn't collect at the time. So at the end, that information from the other project was not useful, and we could not reuse it. So yeah, having the information, the extra information is really necessary, especially for artificial intelligence. But I think we should be careful about which data we need, and because storing everything at the end is just probably wasting resources. That
I completely agree with that. Then, for example, on the other hand, again, by collecting the data if you don't need it, why are you going to measure every second if you only want the data every hour? Because next to the data storage, you also consume energy, chemicals sometimes.
Yeah, and I agree with that. I think that those specific solutions should be optimized. So if you need hourly data, probably you don't need to do it minute by minute. It also depends a lot in what is the purpose of your solutions. So maybe some solutions just need an estimation of the consumption every hour. Having more precise by minutes, it will not make a difference. So yeah, I think that a balance should be achieved there.
I just wanted to approach it with a different perspective because maybe you are focusing on the water data itself, but when you collect the data, for example, from the consumers' usage and things, and then quite often you have the consumers' information as well there. But at the end, when AI want to use this kind of data, that you should only take out the part of the consumption, not to the link with the whole, with the perspective of the consumer, and then the other parts of the consumer's data and stuff like that. At least for the handling of GDPR, when we hold up the data minimization, is that you take out the part, cut off the link of the unnecessary data and things like that. So maybe not about the 5 seconds, 10 seconds and stuff, but about this kind of perspective maybe we can look at.
I'm not an expert in artificial intelligence. That's definitely not what we're doing. But isn't it the part of your AI algorithm to find out what is interesting in your data and what not?
Yeah.
And not you deciding?
No, I'm not the AI part. I'm the platform side. And then not from the NIDES, but from the other parts that when we handle the data minimization, we try to cut the link and then just provide the data only when we provide the context data to the service that originally we get the whole set of data, but from the platform point of view, to provide the data to the AI service, and we cut off, and the other side of the data is we do not provide for the contextual array. So something like this kind of way that we handle. So maybe the AI engineers have a different mindset, but as a platform providers, we try to see in that way the data minimization.
And answering your question, yes, we do that. And we've been actually doing it also for Collusion's case. We had all the data coming in, and then the algorithm decided which are the ones that are really important to actually consider, and then we didn't consider those because they didn't bring anything back.
Okay, that was a good discussion. So let's move to the next question. So, is there a need to boost the digitalization of the water cycle through regulations?
%100% is no.
No, it's just okay. Now it's leave it there. Yeah, I would like to know the both sides on this question, just to have an idea why you think it's not necessary to the regulation for to boost the digitalization. Do you think without any regulation, the digitalization of the water sector of the water cycle will reach to a common place where everybody can just evolve together without regulation? Wouldn't it happen the opposite, that you will have a plethora of solutions, and maybe not that they are not exchangeable between them? It is an open question that maybe.
It's sort of the carrot and the stick approach. The carrot would be the benefits that digitalization brings to a water infrastructure. The stick is regulations. If you didn't take the carrot, the stick is coming for you. We're sort of the same situation with the cybersecurity legislation. For years, everybody implemented as they saw fit, some not at all. And we've seen instances, especially in the United States, for example, where water companies and oil companies have been attacked successfully and caused massive damage at infrastructure scale. Because there was no stick to force them to take such approaches. For digitalization, it's sort of a similar idea. That getting things digitalized will improve efficiency. It's proven. Some do not do it. They're complacent. They like things how they are now, how they've always been. They're comfortable. And doing something like digitalization is scary because it's new. But the stick is scarier. So we need the stick.
Okay, now I understand. I understood the concept.
It really depends from situation to situation. If I look to the Belgian situation, utilities or companies don't need a stick for digitalization. If there's a use case, a business case, they will do it.
In some cases, they may be just all too comfortable with the way things have been going and will be very resistant to change.
That's true, but if you can make a business case, and I believe that this digitalization, companies, CEOs, management is going to push for it.
It's an uphill battle in some cases, unfortunately. The stick just encourages everybody to run uphill faster.
Okay, thank you. Yeah, and now I think I understood better the questions and your answers. Yeah. And I think it will depend from the situation of each company. Maybe they can do it and they will be willing to do it, but others ones, maybe it's not that easy.
Maybe if I can add,
Yep.
well, regulation may benefit from digitalization. Two ways.
How?
Reporting of discharges, reporting of problems, legal reporting, these kind of things. Control of whatever can be made easier by digitalization.
Yes.
That's one of the drivers. And the companies maybe might not be interested in that.
So next question then. So do you think that the European Union should encourage the countries to digitalize the water sector? Yeah, I think that we don't have anything to discuss here. So next one, should the digitalization of the water cycle be supported by public funding?
Maybe the question on the previous one, how do you see that?
How?
How do you think that the EU should encourage?
I think that they are already encouraging, but with some of the topics that they have in their project proposals. I think that on that way, maybe to be so all the water companies are aware of those fundings that help them, and maybe that can be improved. But I think mainly they are. This is already done by the European Union. So.
Basically, you have the stick and the carrot. You have funding and regulation. I guess the next slide is about funding, isn't it?
Yeah. Okay. Yeah, I don't have any comment here. I agree with the majority, but I guess since we are dealing with people working in the water sector specifically, probably for them the funding of the water cycle is more important than the other ones.
That's the wish and
the wish
the reality.
Yeah, I don't know how you can set the which one is more important in general. So I think equally distributed for me, it's okay. So yeah, I'm going to the next one. So how can digitalization support the achievement of the SDG 6 water and sanitation targets?
Can I have a comment?
Yeah, sure.
Yeah, so here, I mean, maybe this, want to hear that what we are doing here is like really, it's in a sense of first world problems that we are optimizing and digitalizing our water systems, and not being, not working on actually where this would really be needed to in the developing countries.
Yeah, probably you are right, but I don't think that there's so much help to improve those other systems. Yeah.
Probably that's also reflected there because, for instance, the second one, the digital or achievement, because those are like there's at the minimum.
Yeah.
So somehow we are recognizing that.
Need first a lot of effort to do on the basis, and then digitalization can help.
Can only like,
As long as the basis is not there.
Exactly. You need to have like, it's like this Markov pyramid. You need to have the first needs fixed before you can go into digitalization.
Some particular aspects that because from the beginning, for instance, having information on the infrastructure that this information It's something that's valuable from the very beginning. It's not so difficult. Free tools are but obviously the aspects out of consideration at the beginning.
Building wastewater systems, like physically building them before digitalizing. Yeah.
I agree with that. So yeah, I'm going to move to the next one. I don't know how many are left. Okay. So the next one is how can we communicate the importance of smart water management to the citizens and to the administration? Okay, I think we are having already some good ones. Maybe also related with Nayades, so if you have a proof of concept to demonstrate and to be promoted properly. Yeah, I agree with that approach. It could be useful. Okay, focusing on use cases that have an added value for your target audience. So I think that one is more specifically if you know the target and it's not to all the citizens in general. No? Yeah, go ahead.
If you communicate, you need to know your audience.
So it is meant, I understood it as for specific sectors in the between the citizens, not the citizens in general, as a target. When for me, I reading the question, the target audience will be not audience, will be the citizens. So when I read the answer, I was thinking that maybe you were applying a specific solution for a small group between the citizens or. Marketing things should be smart, yeah, of course. Gamification. Citizen awareness. Yeah, so basically I see that it's about communicating small demonstrations and yeah, a good marketing to show. But at the end, what you need is to have the solutions to be capable of show something. So. Okay. I think that was the last one.